Thank you, Janet, and thank you very much for the invitation to come here and speak today. It's an absolute pleasure. It's a historical, It's a historical meeting, and I think it's very fitting that we're talking about malaria here. I'm gonna go to some very, very basics for the non-malaria people in the room. So forgive me, all of the malaria people, and some of you who understand all of the basics, but hopefully that'll put everybody on the same page. And then quite a lot of the points that I'll cover will cover either things that we've already heard about or cover some of the questions that have come up. And I'm going to give you a kind of whirlwind tour of how at the Gates Foundation we think, how we think it will, what the pathway to eradication looks like. It is complicated, but we think that it's possible. So first of all, super basic, as I promised you, malaria, what is it? It's a parasitic disease that's caused by a single-celled organism called Plasmodium, and it's transmitted from humans by mosquitoes. It's thought that malaria originated in aquatic algae 600 to 800 million years ago before it evolved to infect birds, and then around 130 million years ago, and then developed into the more modern malaria that we know today that infects humans, rodents, reptiles, birds. There's a specific malaria species for each different animal species. Sir Ronald Ross discovered the malarial parasite in the gastrointestinal tract of a mosquito in 1897 when he was working in India, and proved that malaria was transmitted by mosquitoes. He joined the Liverpool School of Tropical Medicine 2 years later, which was 125 years ago. So I think fitting to mention him today. So we've seen Adrian put up a bit more complex life cycle than this one. But the point I wanted to make here was that malaria needs two hosts. It needs the mosquito and it needs the human. It uses humans to procreate, and only one infectious bite from a mosquito is needed to develop into a full-blown infection. Parasites in the salivary gland of the mosquito enter the skin when the mosquito bites, and then travel to the liver where they infect liver cells. And they start to develop to the next stage. Once that development is complete, tens of thousands of parasites called merozoites are released into the blood, where each one invades red blood cell. The parasite then, as it multiplies, it digests the red blood cell and then bursts out to infect more red blood cells. And this is at the point where you feel the symptoms of the disease. You feel spikes of fever, sweat, nausea, vomiting, exhaustion, respiratory distress, anemia, and often death if the parasite reaches the brain. And if any of you have ever had malaria, or you've probably heard that it really does feel like you're dying when you have malaria. It's a very, very horrible disease. A mosquito that feeds on someone with parasites in the blood will pick up the parasites, which then develop in the mosquito, and then the cycle starts all over again. Malaria is a completely treatable and preventable disease. And Janet mentioned at the beginning of this session that the Gates Foundation held a meeting in Seattle, which was called the Malaria Forum, in 2007. And Melinda Gates stood up and she challenged the meeting to address the elephant in the room. And she said, any goal short of eradicating malaria is accepting malaria. It's making peace with malaria. It's rich countries saying we don't need to eradicate malaria, and the world, as long as we've eliminated malaria in our own countries. That's just unacceptable. A quick side note on what we mean by eradication. It's the eradication from the entire globe of the incidence of disease to bringing it to zero as a result of deliberate efforts. obviating the need for further control measures. This means getting rid completely of the parasite affecting humans from nature. And only 2 diseases have ever been eradicated, smallpox and rinderpest. Both of these are viruses, and vaccinations and surveillance were used to achieve eradication. So there's some very key differences between malaria and between the 2 diseases that have been eradicated from the planet. So what happened? Didn't we already try this? You're probably aware, but when Melinda gave her speech in 2007, as Janet mentioned, it caused quite a stir. And this was because of the previous malaria elimination program in the 1950s and 60s. Many people considered and still consider that the program was a failure. But it did eliminate malaria from 15 countries and 1 territory. Malaria was eliminated from the UK and the US in the 1950s. In the UK, the last indigenous case was in 1957. Changes in land drainage, agricultural practices, better housing, insecticides, and a mosquito that didn't exclusively bite humans were all important factors to get rid of it from this country. And just to mention that one of the reasons why we have such a problem, such a high transmission rate of malaria in Africa is because the main malaria vectors almost exclusively bite humans. When you have a malaria vector that will bite some animals sometimes and some humans sometimes, you're generally going to have a lower burden of disease than when the mosquito is only going to bite humans. There were a number of reasons why the malaria elimination campaign of the 50s and 60s fell apart. It was run in a campaign style that didn't take into account local epidemiological differences that required different approaches. For example, mosquitoes that bite and rest outdoors weren't affected by sprays that were sprayed inside houses, and so transmission in those areas would continue. And there was also development of resistance to the insecticide used to kill mosquitoes and the drugs used to kill the parasite, and so the program started to fail. There was a shift in the epidemic response, and that led to decreased funding, and that led to a decreased effort towards malaria elimination. So where are we today? Well, from the last data from the World Health Organization World Malaria Report in 2022, there was an estimated 249 million cases and 608,000 deaths, with 95% of these occurring in sub-Saharan Africa. Despite the devastatingly high numbers, it's important to understand the efforts over the past 22 years have estimated to have averted 2.1 billion cases and 11.7 million deaths. 44 countries and 1 territory are now malaria-free, including Egypt, that was certified in October of this year. There's, of course, and Sarah mentioned this in her presentation, there's concern that declines that were seen in the early 2000s have stagnated, and this may be in part due to resistance, and so we may be seeing some of the problems from the past starting to emerge again. It's well accepted now that vector control plays a critical role in the malaria eradication agenda. We've seen a massive scale-up of vector control tools, namely bed nets and indoor residual spraying, since the early 2000s, which have largely contributed to the gains that we've seen in malaria over that period. Textiles and nets of one form or another have been used throughout history to help reduce the nuisance from mosquitoes that bite at night. Cleopatra, the last active pharaoh of ancient Egypt, was said to have slept under a mosquito net. And according to the Greek historian Herodotus from 5th century BC, fishermen reportedly used their nets to fish and then during the day, and then they use them for protection from mosquitoes at night. It probably smelled a bit. The big innovation came when insecticides were added to nets in the 1980s, which provided an extra layer of protection. So even if the net had holes, the person sleeping under the net would still be protected. The problem was people, like with bed sheets, they wash their nets. And of course, when you wash your net, the insecticide falls off. And so at the beginning of the 2000s, the first long-lasting insecticidal nets were developed and brought to market. They were designed to withstand multiple washes and last for 3 years. There are two types of long-lasting insecticidal net. One is made with polyethylene, and it has the insecticide inside the fibers, and the fibers are extruded out, and the insecticide gradually migrates to the outside surface. So when you wash it, the surface gets washed off, and the insecticide will migrate from the inside of the yarn to the outside. The other type of net is a coated net, which is a polyester fiber that is coated with a binder that contains the insecticide. When that net is washed, the surface of the insecticide on the binder will get washed off, and then you'll have migration within the binder to the outside surface of the net. So these are the two technologies that have been truly transformational in the vector control space. It provided a hugely cost-effective prevention tool that could be scaled up quickly. But insecticide-treated nets work when mosquitoes feed indoors at night, because people sleeping under them act as a bait. So what else can we use to prevent malaria or reduce the parasite load? Well, the Gates Foundation does not do research, but funds others to do the critical research, and you've heard a lot of the critical research presented today. The malaria team funds against a strategy that has created a pathway to eradication by minimizing the number of deaths along the way. This is through 3 core principles. The first one is to drive down the burden. The second one is to shorten the end game by creating an enabling environment for eradication. And the third one is to get ahead of resistance so that we can mitigate the effects and threats of resistance. The budget for the malaria team at the Gates Foundation is over $350 million a year, and over 50% of that is spent on research and development. So to go into first driving down the burden, a key factor for driving down burden has been to shift from a universal coverage mindset. So, for example, everybody has to sleep under a bed net, and if there's any money left over, then we can add on tools. And this approach has shifted to an approach that optimizes resources for maximum impact. It requires good quality data that can help in choosing the right tool, target where resources are best used, and more efficiently use the limited financial resources that we have available. Technical capacity needs to be built to enable this approach and ensure that it can be scaled up across endemic countries. You heard about chemo prevention, so just wanted to mention seasonal malaria chemo prevention. It's a combination of 2 anti-malarials, so we have sulfadoxine, pyrimethamine, and amidiaquine, typically delivered door-to-door by volunteer community distributors. It's safe, cost-effective intervention. It can be delivered safely at scale, but compliance and adherence to the treatment can be challenging. It's typically given over 4 or 5 cycles, and each cycle gives children 4 doses over 3 days. So you can imagine how difficult it is to make sure that those kids take all of those tablets in order to make sure that they have the protection that they need. New tools aim to overcome these challenges by producing a 1-dose treatment that can last a whole season. And you've heard about some of these already. New product classes being developed include monoclonal antibodies and small molecule long-lasting injectables. And then case management. Improved case management is also critical for driving down burden. We need accurate diagnosis to know whether the symptoms are due to malaria, and new treatment options are needed to address growing drug resistance. Data is needed to change policies to open up availability for new drugs, as well as training healthcare workers to improve access to the right treatment. I lived in Tanzania with my husband and infant son in the early 2000s. We lived in a very remote area with incredibly poor healthcare, and were very, very careful. We were always spraying the indoor walls of our house. We religiously slept under a treated bed net, so every time it was washed, we re-dipped it again. And my son had malaria twice under the age of 2 years old. He also had otitis at the same age, so he would have regular fevers every 2 or 3 weeks. So the poor kid, we had to test him regularly to check whether or not he had malaria. And the other problem is that when you have a young kid, they can't, at that age, they don't speak. They can't tell you they're sick. And my son would play right up until he was about to keel over. And we were incredibly lucky that both times we were actually in Dar es Salaam, in the capital, and were able to visit our family doctor and get a proper diagnosis, treatment. And of course, he was cured, and he's in university today and healthy and doesn't even remember it. But there are many, many people who never, ever managed to get access to good diagnosis and treatment. Next generation surveillance. I mentioned that the importance of surveillance in previous eradication campaigns for smallpox and rinderpest. It needs to focus on enhancing the accuracy, timeliness, and geolocalization of malaria data to improve intervention strategies and support eradication efforts. There are some key components to this. So I've already mentioned a few times resistance monitoring, detecting emerging resistance, enabling early programmatic action, and targeting interventions based on resistance profiles, getting ready for genetic-based vector control. So this is establishing an integrated surveillance system for gene drive and also xenomonitoring for bacterial symbionts, such as Wolbachia, for example. We need to have a better understanding of vector dynamics, identifying mosquito species, blood meals, so what host have they fed on, understanding Plasmodium infections, and looking at shifts in species composition. We need to understand transmission dynamics, so the intensity of infection, distinguishing local from imported cases, and identifying outbreaks as they happen. And then population genomics, so understanding parasite and vector population structure, detecting intervention-induced positive selection, discovering new targets for drugs, diagnostics, vaccines, and insecticides. And these efforts aim to create a robust, affordable, and scalable surveillance system that can support malaria control and elimination programs effectively. One of the most exciting novel approaches on the horizon is genetic-based vector control. Two approaches are being funded by us. One is suppressing a mosquito population, and the other is replacing a wild population with a new strain that can't support the development of the malaria parasite. The main malaria vector species in Africa are being engineered with one of these approaches, and it aims to provide a method of area-wide control that's cost-effective and not dependent on the health system. It's a truly equitable technology, and because mosquitoes move on their own, it can reach those hard-to-reach areas, including in conflict zones. Much of the environment around this technology needs to be built, including lab capacity in Africa, regulatory capacity, comprehensive stakeholder engagement, methodologies for proving public health impact. I think there's some similar issues to vaccine hesitancy that we're going to be needing to address with this type of technology as well. Other biological approaches include the use of symbionts such as Wolbachia and also microsporidia that prevent the development of the malaria parasite within the mosquito once they're present. I'll quickly touch on the vaccine. After 30 plus years of research, we finally have 2 malaria vaccines. It's remarkable and really, truly something to celebrate. I wanted to quote Sir Brian Greenwood from the other school, who said that advances in science are usually incremental. As scientists, we stand on the shoulder of those who have come before us. There remain some significant challenges with the first-generation vaccines, namely the number of doses and boosters required to maintain efficacy, the limited age range, and possibly age-dependent differences in vaccine efficacy. So work is underway to develop a second-generation vaccine that would be higher efficacy, longer duration, and for all age groups, combining antigens from different multiple life stages of the parasite. Another novel approach is to combine a drug that would be a single encounter radical cure. So you heard that being spoken about just now, meaning that it would be one dose and it would kill all parasite stages in the human body and could be given alongside an endecticide. An endecticide is a drug such as ivermectin. You heard David mention that this morning. That once it's in the blood and is ingested by the mosquito, it can kill or reduce the fitness or fecundity of the mosquito. This strategy requires a long-lasting endecticide to make sure that enough people have it in their systems for it at the same time to have the desired effect on the mosquito population. This approach could clear the parasite and reduce enough of the vector population to stop transmission. I wanted to make some brief comments on larval source management. So female mosquitoes lay their eggs in water bodies, which then hatch into larvae and eventually into pupae and then adults. Adding chemicals to breeding sites to kill larvae and prevent adults from ever emerging has been shown to be effective to control malaria. However, it can be difficult to scale and is not always cost effective. Bear in mind that some of these mosquito vectors will put thousands of larvae in a small hoof print puddle. So sometimes it's not the right type of strategy to use. Some breeding sites, they might look like they're productive, but are not actually productive. So there are a certain proportion of breeding sites, you may find larvae in there, but those larvae never, ever develop to pupae and adults. So new technologies may help to solve some of these challenges. For example, mapping using remote sensing through satellites and drones, the use of artificial intelligence and machine learning, algorithms to map productive habitats to generate delivery plans, and the use of drone-based delivery models. Some brief words. We've heard a lot about resistance and the importance of tackling resistance. Getting ahead of resistance, I've mentioned a few times, requires molecular surveillance data to influence policy shifts and enable the use of new tools. The importance of this can't be understated. We have multiple examples now of critical new tools with new active ingredients that just get stalled because the right policies are not there, and a lot of that has been to do with the right data not being available. New insecticides are needed that target different sites in the mosquito than the targets of the pyrethroid insecticides that we've used since the 80s and 90s. And these new insecticides are desperately needed so that we can maintain the effectiveness of our mainstay tool, the insecticide-treated bed nets. And then finally, novel drug combinations with and without artemisinin are needed. And artificial intelligence is already being used in drug discovery to lower development costs over time and find new potential molecules. And I just wanted to mention we're already seeing an impact of the dual AI nets, dual active ingredient nets. We had some great data from Sarah. The impact of these nets in programs is really highlighting the damage that's been done to progress through widespread insecticide resistance and the importance of getting ahead and staying ahead of resistance. Multiple countries using these dual active ingredient nets are now reporting dramatic decreases in malaria incidence following the introduction of this more effective bed net. So, disclaimer, this is a photograph from ChatGPT. So the dog has apparently the right number of toes on its paws. I haven't mentioned funding much yet. Malaria eradication is likely to cost in excess of $6 billion a year. Right now, we're spending roughly $4.3 billion a year. An additional $2 would make a very big difference. We already can't use all of the tools that we already have, and we have a whole load more that are coming down the pipeline, and so we absolutely need to get more funding in. And just as a comparison, I thought it would be helpful to point out that over $13 billion are spent on disposable cups every year in the US. Globally, $5.7 billion is spent on pet clothing, $7.4 billion on flea and tick products, and $5.5 billion on folding pet strollers. Really makes you think. In the spirit of this meeting, I thought we should take a quick look into the past and into the future. So I asked ChatGPT to generate an image of Nigeria under malaria conditions 125 years ago, and Nigeria 125 years from now when malaria has been eradicated. You'll notice that it looks quite like Wakanda, the mythical country from the Marvel universe. I'm assuming that the Wakandans figured out how to eliminate malaria quite a long time ago when Stan Lee wrote that. But these two images highlight exactly the problem that we're dealing with. Malaria is a disease of poverty. There's a cycle of illness and poverty that keeps families and communities from growing and improving. People who live in malaria-infected countries have lower incomes. It affects tourism, foreign investment. They have high health expenditure. Children who can't go to school don't learn, and they don't end up with a better living. Healthy parents can work, earn money, and spend less on malaria treatment and healthcare. One estimate has the malaria costs in Africa at over $11 billion every year in lost GDP. An Africa freed from malaria is likely to become prosperous, more peaceful, and one of the best investments a wealthy country can make. And I just want to conclude by saying that we don't have all of the tools to eradicate malaria today, but they are under development. And as they become available, they will need to be rapidly scaled up. The global community needs closer collaboration. This points to the discussions this morning on the importance of partnership. And an accelerated game plan is needed to ensure that that we can get to an end game acceleration goal sooner rather than later. With all of the issues, climate and various other threats, the longer we push out an eradication goal, the harder it's going to be to tackle it. And with that, I will finish there. Thank you.